do you mean it's already been done?
Well, if you have a barn, you know, and you want to paint it red, you know, if you put a thin paint of red paint, it may not be quite red enough. If you put 2 or 3, then it really looks red. After that, if you add more red, it doesn't make much difference. And so that's sort of what CO2 is doing now, that most of the easy absorption has been done. And so as you add more CO2, you get a little broadening. I don't want to get too technical.
Well, no, I find this fascinating because, and the reason that I find it fascinating is that I hear that, okay, we've gone from about 320, 330 parts per million going back in the last 100 years now to just shy of 400 parts per million if we measure it in Hawaii. And along the way, we've heard predictions of different catastrophic outcomes as we push our way through different maximums. I haven't seen them happening, even though people will attribute some weather change to that. You're saying that if we push through 400 and get to 500, the difference between 350 and 400 is greater than that between 400 and 500. Is that the? Am I right in kind of listening?
There's an interesting thing about CO2, which is unique to CO2. It's not true, for example, of water vapor or methane, and that is that if you get 1 degree of warming from doubling CO2, so going from, say, 400 parts per million for simplicity to 800, that doubles it. Suppose that causes 1 degree of warming. Then to get another degree of warming, you have to double 800, so you have to go to 1600. So you have to double it again. So it gets harder and harder to warm. Technically, they call that the logarithmic dependence of temperature rise on CO2 concentration. It was first guessed at, really, by Svante Arrhenius, you know, who did some of the earliest work on global warming. He thought it was good, you know, he was all for global warming. But he was the first one to point out this doubling property of CO2. Nobody quite knows how he guessed it. It's correct.
Because he wasn't using computer models.
Well, I mean, it was before quantum mechanics, you know, he didn't even know about spontaneous emission. It was before Planck. But nevertheless, he guessed it correctly.
It's quite remarkable, isn't it?
Quite a guy, yeah.
So,